Far below the surface of the Pacific Ocean lies a place so deep, sunlight has never reached it. Nearly 6,000 meters beneath the waves, the sea opens into a vast underwater abyss. This is the Mariana Trench, the deepest known place on Earth, a world of total darkness, crushing pressure, and near-freezing temperatures. Surviving here requires massive, steel-reinforced engineering, like the bathyscaphe Trieste. For decades, scientists believed the physics of this environment made biological survival impossible, but they were wrong. Even in the crushing dark, life found a way. To understand how, we first have to return to the surface and analyze the life support system we are leaving behind. Descending into the trench is a study in subtraction, the systematic loss of every essential ingredient for life. Our journey begins back in the epipelagic zone, the sunlit layer of the ocean. Extending down roughly 200 meters, this is the world most familiar to us. A place of constant movement, warmth, and full-spectrum light. Sunlight reaches these waters, allowing microscopic phytoplankton to survive and multiply. These organisms form the foundation of the ocean. Krill feed on the plankton, fish feed on the krill, and whales feed on the fish. It is an entire ecosystem powered by solar radiation. The architecture of this familiar world is completely dependent on a continuous supply of light. But as we descend deeper, we move beyond the limits of sunlight. The first thing to go is the heat. The warmth begins to fade. Then the water itself begins to strip away the light, absorbing colors one by one, based on their wavelength. The lowest energy wavelengths disappear first. Red vanishes almost immediately. Orange and yellow follow soon after. With these warm colors erased, the environment shifts into a monochromatic world. Blue light is the highest energy wavelength, allowing it to penetrate further than any other color. This descent represents the physical dismantling of the ocean's primary energy engine. Eventually, even the blue light reaches its limit, leaving the water in a haunting, dim hue. There is a definitive moment where the final remnants of light are absorbed by the massive weight of the water above. The solar fuel that drives the entire food web has reached zero. This lightless threshold marks the entrance to the Twilight Zone. If the primary engine of life has been completely extinguished, what power source sustains the creatures waiting in the dark below?
As we plunge past the 200-meter mark, we leave the sunlit surface behind and enter a fading twilight. Down here, the environment undergoes a severe shift. The water temperature drops toward freezing, while the physical weight of the ocean above multiplies, creating immense, crushing pressure. But the most immediate crisis for anything living at this depth is the loss of light. The solar rays that drive vision on the surface are absorbed by the water, leaving behind a thick, encroaching gloom. To cope with this near darkness, prey animals have to maximize the intake of whatever stray photons filter down. Many species have evolved abnormally massive, hypersensitive eyes. These large lenses act like biological satellite dishes, designed to gather the faintest visual data. If a creature cannot build larger eyes to see, it uses a different defense mechanism. By developing biological transparency, these animals allow the sparse, remaining light to pass through their tissue, leaving only a faint ghost of internal organs behind. In these upper boundaries of the Twilight Zone, survival is specialized. Navigating the descent requires either actively hoarding the last rays of the sun or becoming completely invisible within them. As we drop deeper into the water column, we finally hit a boundary where descending sunlight reaches zero. Yet the ocean isn't dark. Up to 80% of the animals swimming through this layer have developed bioluminescence, the ability to manufacture their own chemical light. On the surface, a bright glow is used for illumination. Down here, emitting biological light is primarily used as a form of camouflage. The lanternfish, for example, survives by emitting a soft, downward-facing glow from specific organs lining its belly. This diagram shows how the animal calibrates that glow to match the faint light filtering from the surface. By mirroring ambient illumination, the lanternfish erases its own shadow, dissolving into the background to hide from predators scanning upward. In the pitch-black mid-depths, manufacturing your own light is the only reliable way to hide in plain sight. But biological light isn't strictly defensive. Other animals in this zone weaponize bioluminescence to hunt. The anglerfish hovers in the water completely motionless, operating in absolute silence. Instead of chasing food, it extends a solitary glowing appendage out into the void, twitching it to mimic a smaller, injured animal. In an environment starved of light, a bright, moving beacon acts as a magnet, pulling curious prey directly toward a set of unseen jaws. The moment a fish breaches the proximity threshold, the trap triggers. Biological light in the deep ocean is a dual imperative. It allows prey to survive the darkness, while providing predators a lethal trap. Eventually, we reach the 1,000-meter boundary. The ocean here falls still, and the environmental hostility reaches its peak. This extreme depth is home to the Siphonophore, an organism whose structure challenges the standard definition of a single animal. Floating weightlessly in the abyss, it appears to be a massive, continuous glowing chain, sprawling outward in a unified structure. But a Siphonophore is actually a colony. It is composed of thousands of individual, living organisms structurally fused together to operate as a singular unit. This schematic reveals a strict division of labor. Clusters act as hunting modules, others serve as propulsion nodes, and segments handle reproduction. Interdependency is absolute. If an individual is severed from the chain, it lacks the tools to function alone and fails to survive. The journey to the edge of the Twilight Zone reveals how life occupies the Earth's most hostile conditions. Through transparency, bioluminescence, and colonial cooperation, these creatures
Far below the Twilight Zone lies a world beyond the reach of sunlight entirely. For centuries, the scientific consensus held that this deep ocean floor was a barren, terrifying wasteland. The logic was simple. Without solar energy, there was no foundation for complex life. Humanity viewed the deep ocean not as a potential ecosystem, but as an impenetrable, lifeless void. The darkness is only part of the challenge. Down here, life must contend with extreme hydrostatic pressure. This diagram shows the scale of that weight. The pressure here is more than 1,000 times greater than what humans experience at sea level. At these depths, the physics are absolute. An unprotected, rigid vessel would collapse instantly. To survive, human explorers must rely on specialized engineering. This thick, spherical cockpit is designed specifically to withstand that crushing force. Because the physical barriers were so extreme, they created a massive vacuum in our understanding of the planet. But as deep-sea exploration advanced, the long-held myth of the dead void began to fall away. This is the frilled shark. Finding it here, active and thriving in the crushing depths, forced a complete reevaluation of the limits of biology. These creatures don't survive by fighting the pressure with rigid armor or brute strength. Instead, they use soft, flexible body structures that allow internal and external pressures to equalize with their environment. The abyss didn't crush life. The pressure meticulously shaped a biology built for endurance. Once the hurdle of pressure is cleared, animals must face a second constraint, the total scarcity of food in a lightless world. The solution to this scarcity is a life defined by extreme energy conservation. Every movement is slow and calculated to ensure precious reserves are never exhausted. In the deep sea, nothing is wasted. Every calorie burned is a necessary survival strategy. The Mariana Trench is not a place of chaotic struggle. It is an environment of incredible biological precision and patience. When we look at the evidence, our view of the Mariana Trench shifts. Hidden beneath kilometers of water, it is quietly, silently alive. A complex ecosystem persists here, thriving against odds that would be impossible for any other life on Earth. By replacing historical assumptions with these scientific realities, we can finally see the abyss as it is, a place of profound, quiet wonder. The deeper humanity explores the ocean, the more we realize how little we truly understand about our own planet. We don't need to look to outer space to find an alien world. This massive expanse of blue hides one right beneath our feet. Somewhere in the endless darkness below countless mysteries are still waiting to be discovered. In the deep, life endures through a tenacity we are only just beginning to grasp, leaving us with a planet full of